Okay, in this video we're going to cover independent events. So independent events basically mean that one event is not influenced by another. And a good example of this would be a bag of counters. So let's draw our bag of counters. Maybe we'll have some blue. So let's do 3 blue and 2 red. So we wanted to know the probability of getting a red. So the probability of getting a red is 2 out of 5. Okay, so we've taken that red out, and let's say what's the probability then of getting another red? So we now only have 4 counters and one of them is red. So the probability of getting the second red is now 1/4. So the second probability is influenced by the first, so they're not independent. But let's say we were to, just see if I can undo this, do replacements. So we put it back in. So we took the red one out and it's 2/5. So we took it out, but then we put it back in and the probability is 2/5. So when you have with replacement, they're independent, and without replacement is not independent. Another example is if we were to flip a coin. Okay, every time we flip that coin, the probability of getting a heads is 0.5. It doesn't matter if we had tossed 100 tails before it, the probability of getting a heads is still the same. Okay, so they're independent of each other. There is a formula for independent events, so you can see it here. Okay, so it's a good idea to put this into your bound reference. And this formula will be used, and you'll see when we do question 4. Basically, the probability of A given B is equal to the probability of A, or B given A is equal to the probability of B. Or the second one is the probability of A and B is equal to the probability of A times the probability of B. So you need to know these formulas because you might get a question that says for independent events, and then you need to apply the formula. It's the same with the addition rule. Sometimes you're given the values and you have to kind of solve it using algebra. All right, let's move on, otherwise we might be here for a while. Question 1. Okay, of 17 leading accountants, 15 offer advice on tax, whereas 10 offer advice on business growth. 8 of the accountants offer advice on both tax and business growth. One of the 17 accountants is chosen at random. Okay, so use a Venn diagram. Now, I'm not a fan of Venn diagrams, so I'm going to continue doing two-way tables first. So tax, not tax, business growth, not business growth, and we have 17 in total. 15 offer advice on tax, 10 offer advice on business growth, and 8 on both. Okay, so remember, then we just complete our table. 2, 2. Okay, so then I can do a Venn diagram. So if you have trouble doing a Venn diagram, there's nothing wrong with doing a quick two-way table. So we have tax and we have business growth. So 8 do both. 7 do tax but not business growth, and 2 do business growth but not tax, and we have 0 out here. So let's just make sure it adds up to 17. So 7 and 8 and 2 do add up to 17, so we've drawn it correctly. Okay, the probability of T. Okay, I prefer to go from my two-way table. So if you're doing it from the two-way table, it's 15 over 17. Or you can do it from your Venn diagram. Just remember everything in that T circle is with T, so 7 and 8. T only is just 7. Okay, so T but not business growth out of 17. and then t given g. So you can use the conditional probability formula, or you can just go straight to your Venn diagram. So if we do given g, it's this whole circle here. How many in this circle do tax? 8 over 10, which simplifies to 4/5. Or you can use the conditional probability formula, which is the probability of t and g over the probability or number. So you can use number, you don't have to use probability. T and g is 8, and the probability of g is 10. So you can see how you can use the formula if you prefer, if it's too hard to read it from the Venn diagram. Okay, a bit of writing on here, so let's see if we can fit the final question in. Are the events t and g independent? So this is where you need to use your independent, we'll check using this formula. So the probability of A and B equals the probability of A. So let's just put that back. So this time we're using T and G. T given G, not probability of TIG, is the probability of T. So we worked out the probability of T given G is 4 over 5, and I'm going to be writing over that. And the probability of T is 15 over 17. And they're not equal, so it does not equal, therefore they're not independent. If they were equal, then they would be independent. Okay, let's move on. Question 2. So the reason question 2 is here, and I think also for question 3, is there are just examples of independent events. So as I said before, tossing a coin and getting a heads or a tails is always independent of what you did beforehand. Okay, the coin doesn't magically say, oh, you just did a tails, I'm going to give you a heads now. Okay, it's completely random and it's going to be 0.5 every time. Okay, so the probability of 5 heads. You can do this on a tree diagram if you want to, but you don't need to. Okay, we've got 5 heads here. The probability of getting a head, and if you think about it on a tree diagram, we're basically doing this. Actually, sorry, I should start there. 1, 2, 3, 4, 5. And remember, when we have a tree diagram, we have the probabilities on the branches. And when we want to know all of the possibilities, we multiply our branches. And that is the same as half to the power of 5. And that gives you 1 over 32. Okay, so just recapping that, 5 heads. You could draw a tree diagram, but that's a pretty big tree diagram. This is only one branch. You have many, actually you have 32 different possibilities. But if you know the probability of one head, and you can kind of picture it in your head what it would look like, it's just a half times a half times a half times a half times a half. The probability each time does not change. It can also be written as a half to the power of 5, which is 1 over 32. You should know how to do this. Remember when we did our index laws in term 2, or you could say 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So quite easy to do in your head. All right, let's move on to the next one. At least one tail. So there's many different possibilities of doing at least one tail, but basically you can say, well, the probability of more than or equal to one tail, one tail is equal to what we don't want. So 1 minus the probability of getting all heads. Okay, which we just did. So 1 minus 1 over 32, okay, because this is the only option we don't want. And this will include everything else. So 5 t's, 4 t's, 3 t's, 2 t's, 1 t, all the possibilities. So instead of writing them all out, you can say, well, what don't I want? Well, I don't want 5 heads. So I take that away because all your probabilities should add up to 1. Now, at least one head. Oops, what did I do there? I wrote the answer. I think I was talking at the same time. It should be 31 over 32. Now, the next one, the probability of getting greater than or equal to one head is the same, okay, because your tail and your head are the same probability, okay, so it's a half and a half. So your probability of getting at least one tail is the same as at least one head. Okay, let's move on to question 3. So a fair 6-sided die is rolled 3 times. Find the probability that the sum of the 3 dice is. So your dice, or your die, every time it's rolled is independent. Okay, if I roll a 6, the dice doesn't think, oh, next time I can't roll a 6. Okay, it doesn't have a mind of its own. It is completely independent. Okay, so if we've got 6-sided dice, or die, the probability of getting 18, and we're doing the sum. Okay, so we're rolling it 3 times and we want the sum of 16. Now there is only one option for that, and that's to get 6, 6, and 6. You can't roll the die any other way to get a total of 18. So the probability of getting 1 6 is 1 over 6. Okay, and because they're independent, it doesn't change. I don't know whether you can remember now what 6 to the power of 3 is. It's 216, something that you should know going into methods. Okay, the next one, the probability of 3. Now when you think about it, there's only one possible way you can get 3 is to roll a 1 3 times. And to roll a 1 is the same probability as rolling a 6. So 1 over 216. Now, for the next two, there are different possibilities. So you need to actually write them down. So to get a sum of 4, we can have 1, 1, 2. Sorry. What else can we have? 1, 2, 1, 2, 1, 1. So we have 3 different ways of getting 4. Now the probability of getting one of those, and let's just call it x, is 1 over 6 times 1 over 6 times 1 over 6. So that's 1 over 216. But we've got 3 possibilities, so we've got to add them all up. So your total prob, what do we want? 4. Or sum of 4. Actually, let's do the notation, proper notation. So sum of 4, we use that, is 1 over 16, oh sorry, 216 plus 1 over 216 plus 1 over 216, because each of these is 1 over 216, which is 3 over 216. Yes, so 3 does go into 216. How I did that is I just went to 210. 3 goes into 210 70 times and then into 6 twice, so it's 1 over 72. Then for the last one, let me just clear this. All right, so to get the sum of 5, just perhaps write down all your possibilities. So I can have 1, 1, 1, oh, no I can't, sorry. 1, 1, 3, and I can just alternate them. And then I can have 1, 2, 2, and 2, 1, 2. So I've got 5 different ways of doing it. Remember, I've already worked out what it's going to be. So the probability of getting one way is 1 over 216. And we have 5 of them, so we've got to multiply that by 5. And I actually forgot one, didn't I? 221. Multiply that by 6. So that is equal to 2 over 216. Now I know that can be simplified because we've got 2 even numbers here. So instead of thinking how many times does 6 go into 216, I'm just going to halve it. and that's going to be 108, and 3 does go into 108. I know 3 goes into 90 30 times. Is it 33? Gosh, I'm just going to have to pause it to check. Sorry, 36. Okay. 1 over 36. Yeah, sorry. 3 goes into 18 6 times, not 3 times. All right. Doing the simplifying your fractions, you do need to be able to do going into methods, and you can't simplify 1 over 216, so you do have to simplify it at the end. Sometimes it would be easier to simplify it and then add. All right, let's move on to question 4. So question 4 is actually quite difficult because it's told us that two events are independent. Okay, so in each case, find the value of x so that a and b are independent, and they've got the independent formula here. So we need to use that to work out the value of x. Now, just before we do that, remember that the conditional probability formula, so the probability of A given B is equal to the probability, and I'm going to run out of room here, A and B over the probability of B. So for each of these, we can use this formula. Okay, so the probability of A is, we've got 2 and 3 in A over the total number. So we've got 2, 3, 6 plus some number, we don't know what that is. So we just write 6 plus x, and then the probability of A given B. So we've got 1, that is A and B, okay, so A and B. And then the probability of B is 4. And then we just have to solve. So you can do solve on your calculator if you like, or you can just quickly do it by hand. So I'm going to multiply both sides by 4 and put on the spot here. So I'm just going to get rid of that to be 1. When I multiply that by 4, I get 12 over 6 plus x. Whoops. And then I'm going to put the 6 plus x over to the other side. So that means x is equal to 6. And if you need to check, just substitute it back into here, which I just quickly did in my head. So that makes it 3 over 12, which is equal to a quarter. So in the first case, x is equal to 6. All right, moving on to B. So we do the same thing. So the probability of A is 11 and 1, which gives you 12. Then the total, so we have 11 and 1, and then 2 is 14, plus this x. So remember, we always include what is on the outside, but in this case we don't know what it is. So we just put it there as some unknown, and that's what we've got to solve for. Okay, then A given B, so the probability of A and B is 1, or the number, over B is 3. Okay, and then just solve. So I'm going to multiply both sides by 3 first. There are many ways you can solve algebraic equations when I'm put on the spot. It's just how I'm doing it. You could flip your, flip your fractions, which might be easier. Maybe we'll do the next one like that. And then x is equal to 36 take away 14, which is 12. And then let's just put 12 up there. So that gives us 36. No, it gives us 26. 22. Sorry. 22 and 14 gives us 36. Good. So x is equal to 22. If you want, have a go at doing C and D, and then you can check your answer, or you can keep following me. Let's go quickly this time. So the probability of A is 9 over 9 and 14 gives me 23 plus X is equal to 2 over 16. Now, before I was saying you could flip your fraction if you like, or you can simplify this to 1/8 if you like. So I'm going to do that in one go. So 23 plus X over 9, and I'm going to simplify this to 1/8. So this is going to become, when I flip that, it's going to become 8. So 23 plus X, now multiply 9 and 8, 72. So X is equal to 72 minus 23, 49. But if you've got your calculator, you can just use solve on your calculator. All right, last one. So we might need to just scroll up a bit. Okay. This time we have our unknown inside A. So I can just write that as X plus 1 over the total. So now we have going to have X twice. So we've got 1, 2 is 3, and 4 is 7. So 7 plus, or X plus 7 is equal to 1 over 3. Okay, so let me just think of the best way to do this. Okay, let me just pause because I don't want to do the long way. Okay, it is late, so I'm just going to do it the way I would actually do it. But as I said before, with algebra, there are many ways you can solve the problems. I'm just going to flip the fractions just to get rid of that 1/3. So it's going to be just 3 now. If I multiply both sides by X plus 1, so I've got X plus 7, and then this is going to be 3X plus 3. And then I can just solve. So I'm going to bring my X's onto one side. So I'm going to have 2X. So I've brought that X over just because I don't want to deal with negatives. And then that 3 over to the other side will give me 4. And that makes X equal to 2. So let's just substitute this back in to double check. So if I have 2 plus 1 is 3, and 2 plus 7 is 9. Whoops. Which is equal to 1/3. Fantastic. So X is equal to 2. But remember, you can use solve on your calculator. All right. Good stuff. Bye-bye.